Hello everyone. Hello everyone. Today we shall discuss data handling, that is chapter number 5. Looking for information. In your day-to-day life, you might have come across information such as runs made by a batsman in the last 10 test matches, number of wickets taken by a bowler in the last 10 ODIs, marks scored by the students of your class in the mathematics unit test, number of story books read by each of your friends, etc. The information collected in all such cases is called data. Data is usually collected in the context of a situation that you want to study. For example, a teacher may like to know the average height of students in her class. To find this, she will write the heights of all the students in her class, organize the data in a systematic manner, and then interpret it accordingly. Sometimes data is represented graphically to give a clear idea of what it represents. Do you remember the different types of graphs which we have learned in earlier classes? Pictograph. Pictorial representation of data using symbols. This is a pictograph. So this pictograph picture of car represent 100 cars. One symbol stands for 100 cars. Here is 1, 2, half, that is 250, and denotes half of car denotes 1 by 2 of 100. That is 250, 1, 2, 3, that is 300, 1, 2, 3, 4, that is equal to 400. How many cars were produced in the month of July? That is 250. In which month were maximum number of cars produced? That is in the month of September. Right? A bar graph. A display of information using bars of uniform width, their heights being proportional to their respective values. Here you see, this is academic years. This is number of students in class 8, that is 50, 100, 150, 100, 200, 250, 300, 350. In the horizontal, 200 to 2003 to 2004, 2004 to 2005, 2005 to 2006, 2006 to 2007, 2007 to 2008. This is academic years. Bar. Heights give the quantity for each category. Bars of equal Bars are of equal width with equal gaps in between. What is the information given by the bar graph? In which year is the increase in the number of students maximum? In which year is the number of students maximum? State whether true or false. The number of students during 2005 and 2006 is twice that of 2003 and 2004. This is bar graph, right? Now we shall discuss about double bar graph. Here you see, this is the representation of double bar graph. A bar graph showing two sets of data simultaneously. It is useful for the comparison of the data. You see, this is maths, social science, science subjects, English and Hindi, and marks obtained by student 10, 20, 30, 40, 50, 60, 70, 80. Right? What is the information given by the double bar graph? In which subject has the performance improved the most? In which subject has the performance deteriorated? In which subject is the performance at par? This is the double bar graph to compare. You see, this is 2005 to 2006, and this one is 2006 to 2007. The comparison of maths in the 2 years, comparison of social science in the 2 years, comparison of science in the 2 years, comparison of English in 2 years, and comparison of Hindi in 2 years. Organizing data. Usually, data available to us is in an unorganized form called raw data. To draw meaningful inferences, we need to organize the data systematically. For example, a group of students was asked for their favorite subject. The results were listed below: art, mathematics, science, English, mathematics, art, English, mathematics, English, art, science, science, mathematics, art, English, art, science, mathematics, science, art. Which is the most likely subject and which one is least liked? It is not easy to answer the question looking to the choices and the choice is written haphazardly. We arrange the data in table 5.1 using tally marks. Here see art number of students 7, mathematics 5, science 6, and English 4. The number of tallies before each subject gives the number of students who like that particular subject. This is known as the frequency of that subject. Frequency gives the number of times that a particular entry occurs. The frequency of students who like English is 4. Frequency of students who like mathematics is 5. This table made is known as frequency distribution table, as it gives the number of times as entry occurs. This is the frequency distribution table. Grouping data. The data regarding choices of subjects showed the occurrence of each of the entries several times. For example, art is liked by 7 students, mathematics is liked by 5 students, and so on. This information can be displayed graphically using a pictograph or a bar graph. Sometimes, however, we have to deal with a large data. For example, consider the following marks out of 50 obtained in mathematics by 60 students of class 8. If we make a frequency distribution table for each observation, then the table would be too long. So, for convenience, we make groups of observations, say by 0 to 10, 10 to 20, and so on, and obtain a frequency distribution of the number of observations falling in each group. Thus, the frequency distribution table for the above data can be groups 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. This is tally marks distribution 0 to 10. The frequency is 2, 10 to 20, frequency is 10, 30 to 20 to 30, 21, 30 to 40, 19, 40 to 50, 7, 50 to 60, 1. The total frequency is 60. Data represented in this manner is said to be grouped, and the distribution obtained is called grouped frequency distribution. It helps us to draw the meaningful inferences, like most of the students have scored between 20 and 40. Eight students have scored more than 40 marks out of 50, and so on. Scored more than 40 marks. Each of the groups 0 to 10, 10 to 20, 20 to 30, etc. is called the class interval, or briefly a class. Observe that 10 occurs in both the classes, that is 0 to 10 as well as 10 to 20. Similarly, 10 to 10 or 20 occurs in classes 10 to 20 and 20 to 30. But it is not possible that an observation, say 10 or 20, can belong simultaneously to two classes. To avoid this, we adopt the convention that the common observation will belong to the higher class. The common observation will belong to the higher class, that is 10 belongs to the class interval between 10 to 20, not 0 to 10. Similarly, 20 belongs to the 20 to 30, not belong to 10 to 20. In the class interval 10 to 20, 10 is called the lower class limit and 20 is called the upper class limit. Similarly, in the class interval 10 to 20, 20 is the lower class limit and 30 is the upper class limit. Observe that the difference between the upper class limit and lower class limit for each of the class intervals 0 to 10, 10 to 20, 20 to 30, etc. is equal 10 in this case. The difference between the upper class limit and the lower class limit is called the width or size of the class interval. Let's see frequency distribution. Study the following frequency distribution table and answer the questions given below. Frequency distribution of daily income of 550 workers of a factory. Class interval 100 to 125. Daily income in rupees. Number of workers 45. 125 to 150 25. Like this, 150 to 175 55. 175 to 200 125. 200 to 225 140. 225 to 250 55, 250 to 275, 35, 275 to 300, 50, 300 to 325, 220 and total 550. Now, bars with a difference. Let us again consider the group frequency distribution of the marks obtained by 60 students in mathematics text. Class interval 0 to 10, number frequency 2, 10 to 20, 10 to 20, 10, 10 to 20 to 30, 21, 40, 30 to 40, 19, 40, 57, 50, 61, totally 60. This is displayed graphically as in the adjoining graph. This one marks up the students and number of students. This graph in any way different from the bar graphs which I have drawn in class 7. Observe that here we have represented the groups of observation, that is class intervals, on the horizontal axis. The height of the bars show the different frequency of the class interval. Also, there is no gap between the bars, as there is no gap between the class intervals. The graphical representation of data in this manner is called a histogram. The following graph is another histogram. You see, this is also a histogram. This is jagged line. Jagged line or broken line has been used along the horizontal line to indicate that we are not showing the numbers between 0 to 20. This is number of teachers, ages of 25 teachers of a school. The range is divided in equal intervals, that is of 5 years in this case. Bars of equal width with no gaps in between. Height of the bars gives the number of data items in a particular group and is the frequency. From the bars of this histogram we can answer the following questions. That is, how many teachers are of age 45 years or more but less than 45 years or more but less than 50 years, that means 5. Here you see this is 5. How many teachers are of age less than 35 years, less than 35 years? This is 0 to 35, less than 35 years. You have to count this one, that is 4 plus 5, 9, 9 plus 6, 15. Now this one, observe the histogram and answer the questions given below. This is also a histogram, heights in centimeter and number of girls of class 7. What information is being given by the histogram? Which group contains maximum girls? How many girls have a height of 145 centimeter or more? If we divide the girls into the following 3 categories, how many would there be in each? 150 centimeter and more. Group A, 140 centimeter to less than 150 centimeter, that is group B, and less than 140 centimeter, that is group C. Right? In this way, you have to make the different histograms. Dear friends, if you like this video, please subscribe, like, and share. Thank you everybody for watching this video.